Hello friends, welcome back to my channel. In this video, we will see how the transformer architecture works and we will discuss about each of the module which are present in a transformer architecture in detail. So let's first discuss what are the topics we are going to cover in this particular video. So first we will see what is transformer architecture. So we will see first in brief what is this. Okay, then we will see what is attention mechanism. Okay, so I will talk about a little bit here and in detail I will talk about this in the next video. Then we will discuss about this working of the transformer architecture and we will majorly spend our time for this particular part here. In this particular video we will discuss each and every module of the transformer architecture, and then the next is the evolution of transformer architecture. Because the video will become very big, so I will cover this particular part in the next video, where we will discuss how it got evolved from a simple RNNs to the state which it is present today, which we are using, or the most of the LLMs use this transformer architecture. So how it got evolved, we will see that step by step in the next video. So let's start this particular video by discussing what is the transformer architecture. Okay, so what is this? So it is an architecture on which several LLMs work today. So this is the base of several LLM models which we are using in today's world. So for example, the GPT, which is the underlying model of ChatGPT. So this particular GPT model uses this transformer architecture itself. So the base of this GPT model is this particular transformer architecture. Similarly, the Google Bard also uses this transformer architecture. Okay. Now let's move forward. So what is attention mechanism? So I will briefly discuss about this so that you would get a overall idea about this. But in detail, we will discuss about this attention mechanism and the self attention, all of these things in the next video, where we will discuss the evolution of this transformer architecture and how this attention concept came into picture, and why is it so much popular now. So we will discuss that while we will discuss the evolution of transformer architecture. So let me just discuss briefly here what is this. So if I talk about the attention, the meaning of attention in general terms, in the simple English language, so it is the ability to focus on one thing. Okay, so in the attention is the ability to focus on one thing, and we ignore the other things which are not relevant or which are irrelevant at that particular moment of time. So that is the attention. You know the meaning of attention. Okay, now let's see what it means in terms of the machine learning. So in machine learning, we apply this particular concept, this attention mechanism, by teaching the model to focus on certain parts of the input data. So we provide the data and we are teaching the model so that it can focus on certain parts only and disregard other parts, so that it can solve the problem or solve the task in a better way. Okay, so if I summarize again, so in this attention mechanism, we are just teaching the model to focus on certain parts of the input data and disregard other parts, so that the problem can be solved in a better way. So that is the attention mechanism. Now let's move forward. So let's now start the discussion of the working of transformer. Okay, this is the main part here which we are going to discuss in this particular video. So if I talk about when the transformer was not in picture, so then the most advanced architecture we were using for NLP was this NLP with LSTM or the GRU units. Okay, so this was the most advanced architecture, but there were two majorly drawbacks. Like the first one was, it these architectures were not capable to process very long sequences. Okay, even if we use this LSTM and GRU units, then also we were not able to process the very long sequences using these architectures. So this was the first drawback. Then the another drawback was because they were in sequential in nature. Okay, because they were only capable to do the processing in sequential manner, so we could not do anything in parallel, and that is why they were slow. They were slow in processing because the parallelism was not an option if we are using those architectures. But if I talk about the transformer architecture, then these two drawbacks got resolved. Okay, so now when we are using the transformer architecture, so we can work on long sequences as well as some part of the architecture can be processed parallelly. Okay, so some part of the architecture can be processed parallelly, and because of that the training the the training part of the model, it became much faster. So that those two problems got resolved when we are using the transformer architecture. Now let's see the different module of this transformer architecture. So first of all, transformer architecture has two parts. First one is the encoder, the second one is decoder. So let me show you the image also. So if I show you the image, so this is the encoder part, so this left part is the encoder part. Okay, and this right part is the decoder part. So let me show you the entire picture. So this is the decoder part, the right part is the decoder part. Okay, now let me go back to the section where we were. Now some of the LLMs are based on encoder only transformers, so which means the some of the LLMs use only the encoder part of this particular transformer. Like for example, the BERT is one of the example which uses only the encoder part, and some LLMs use only the decoder part of it. For example, the GPT-3, GPT 3.5 or GPT-4 or any models which are based on GPT-3. So all those LLMs use only decoder part. They do not use the encoder part at all. Okay, and some LLMs are there which use both of these part, the encoder part and the decoder part. For example, T5 is one of the LLM, the BART is another LLM which use both of the parts of this transformer architecture. Let's now discuss. So in this particular video, we will focus on the decoder part on which our GPT models are based. Okay, so we will discuss each and every module of this decoder part in this particular video. So first, let's discuss about this particular module, which is this output embedding. Okay, so what is the responsibility of this? So this converts the words, the whatever input we have given, so this converts those words into the vectors. And now you would ask, what is vector? So vector is just a series of numbers which are separated by commas. So there can be 3 numbers, 5 numbers, hundreds of numbers. But if I talk about the LLMs which we are using, so we typically use 5, 1, 2 numbers. Okay, so the vector size is 512 numbers which we are using typically in any LLM today. Okay, so this is output embedding. Now we call this output embedding because the output of previous run goes into the model again as the input. So we can call this input embedding or the output embedding. This is the same thing. Okay, so I hope you already know that any LLM works like when we give some input text. Okay, so it generates only one word as the output, then it appends that one word in the input after the input, and then it goes again, the entire input plus that new word goes again to the model, and it now guesses the next word. Then again the output goes back to the model and it now generates the next word. So that's how it works. I hope you already know this. So the output of first run goes again to the model as the input, so that's why we can call this input embedding or the output embedding. Okay, so this was the first module. Now let's talk about the second module, which is this positional encoding. Let me show you in the image as well. So this is the positional encoding. So let's see what is the work of this. So this module adds the positional information. what do I mean by positional information here? So the positional information is the positions of a word in a particular sentence. So let me give one example and it will be more clear after that, and I will also explain the importance of these particular positions of a word in a sentence. So let's see this particular sentence. Cat eats apple. So if I talk about this particular sentence, so this is grammatically correct sentence. Okay, and this also makes sense. So if I talk about this particular sentence, so this is grammatically correct as well as this also makes sense. But if I just change the position of this particular word and this particular word, so this sentence will become now apple eats cat. So if I talk about this particular sentence now, so this is also correct grammatically, but this new sentence does not make any sense at all. Okay, I hope you are getting what I am saying here. So this sentence, just we have changed the positions of two words here, and this is also correct grammatically but does not make any sense. Okay, so this particular example, through this example we can say that the ordering of words are very important in a sentence. Okay, so this, what is the responsibility of this particular positional encoding module is that it helps the large language model to remember the ordering of words in which they came when we have provided them as the input. So when we have given the input text to the model, so it remembers the ordering of those words which are present in those sentences. Let's now talk about the next module, which is this masked multi-head attention. Okay, so let's talk about this. So this is actually the heart of the transformer because this captures the contextual information about the data, the input data. Okay, so let me give one example so that it will be more clear to you. So let's see one sentence which is the artist didn't finish the painting because it was too complex. Okay, so now if I ask you this particular it, whom it is referring, so it is referring to the painting here. Okay, now if we change just one word in a sentence, in this particular sentence, this one word complex, okay, and the sentence is now the artist did not finish the painting because it was too late. So we just change this particular one word in this sentence. Now the meaning of this it got suddenly changed, and now this particular it is referring to the time, not the painting. You are getting right what I want to say here. So what we can say now, so the meaning of individual words in a sentence can be affected by other words in a sentence. Okay, like we saw earlier, the meaning of that it got changed because of the other words which were this complex and this late. Because of the other words, the meaning of this particular it word got changed. Okay, so this is called the contextual meaning, right? This is called the contextual meaning. So the this particular module, so the purpose of this particular module is to capture this particular contextual information, and it enriches that information into the module. Okay, rather model. Okay, so this particular module is responsible to capture this particular contextual information and it enriches that information into the model. And that's why we can say that along with the semantic meaning is the dictionary meaning. So along with the dictionary meaning, the contextual meaning is also important, and this particular module captures that contextual information. Okay, let's move to the next module now. So the next module is this feed forward network. Okay, let's talk about this. So this module helps to increase the learning capacity of that particular model. Okay, this is the main responsibility of this. How is it doing that? So because this is a deep neural network and which has several layers and the activation functions. So because of that, it increases the learning capacity of the model, and this particular neural network enables the model to learn even more complex relationships between words which are present in the input sentence. Okay, let's now move to the next module, which is the last module. So which is this particular output module. So what is the responsibility of this module? So it is responsible to provide the output. What it does for that, so it takes all of the words which are present in the English language, and it assigns the probability score to each one of those words, so that it can be decided which will be the most likely next word on the basis of that probability score. Okay, so whichever word will have the maximum probability score, that word it would give as the output. So that is the responsibility of this output module. Okay. Okay, so these were the modules. Let me just give you the revision briefly. So first we discussed the output embedding, where it converts the words into the vectors. Then the positional encoding, because the positions are very important in a sentence, so it remembers the positions of words in a sentence. So that's the responsibility of this particular module. Then the next module is this masked multi-head attention, which is the heart of this particular transformer, and which captures the contextual information of the input data. Then comes the feed forward neural network, which is a neural network, or which is a deep neural network, and it enhances the learning capability of the model. And at last, the output module, which gives the output. Okay, I hope you would have understood the working of each module which are present in the transformer architecture. Now in the next lecture, we will see the evolution of transformer architecture, how it got evolved from the simple RNNs to the current state which we are using today of this particular transformer architecture. So we will see that step by step how it got evolved. Okay, so that's all for this particular video, and do let me know how did you find this particular video, how useful this was, and if you got to learn anything new from this video, then do hit the like button and do not forget to subscribe the channel if you want to learn more about generative AI and the data science. Let's catch up in the next video. Till then, stay safe and keep learning, keep supporting.